All right. So the way this section is set up, the way chapter 1 is set up, is that a lot of times, oh no, hit the wrong button. Sorry about that. There we go. So there may be some things in here that we may it may go over, and it may anticipate you guys already knowing this, because remember, this is pre-calculus. If you have any questions on anything, make sure you get with me. Why is this not showing up like I needed to? All right, well, you guys can see my note sheet, right? For some reason, you guys aren't staying up there. Everybody can see my notes as linear equations and rational equations.
Yes, sir.
Okay, great. For some reason, it's acting a little funky on my end. Okay, as long as you guys can see it, then that's fine. So, if we go over factoring, or it's not going to go over factoring, but if you need factoring help, then make sure you get with me outside of class. I have plenty of videos that I've talked about factoring in other classes as far as lectures are concerned. Or if you just need to sit one-on-one in another or outside, separate Zoom session, feel free to email me so we can, discuss that, on my YouTube channel that I've been, recording lectures and everything. Got pretty much lectures on everything, developmental courses, all the way up to calculus. So, yeah, just let me know if you need any help on some background things, and go from there. So 1.2 is linear equations and rational equations. First thing, we're looking at solving these. And an equation is a statement that two algebraic expressions are equal. I want to write each expression better than that. Two algebraic expressions are equal. So an example of that is x plus 5 equal to 7. That's just a simple example of an equation. X plus 5 equal to 7. A solution is going to be a value or values that will make an equation true. So x equal to 2 is the solution for this equation. If you were to plug in 2 into that equation for x, 2 plus 5 is equal to 7. So whenever you're going to solve, you want to ask yourself, when is x plus 5 equal to 7? Or when is your statement true? The answer is when x is equal to 2. So you're always trying to ask, whenever you're trying to solve, when is that statement true? That will be the answer to that question, or the solution for that equation. Also, don't forget that your cameras aren't enabled, and that's fine for the lecture. But if I've already written all my notes out, if I start to go too fast, I can't see if you're still writing. I can't see if you're confused or anything like that. So I don't know, if I go too fast, I don't know to slow down unless you let me know, or if you need me to re-explain something or to go back, that will be all on you guys to let me know what's going on. All right, so we will solve by what I call opposite operations. There are operations that will undo what the other one does. So addition and subtraction are opposite operations. Multiplication and division are opposite operations. So when we look at that x plus 5 equals 7, your goal is to undo what's being done to your variable. You need your variable by itself. Remember, we had x equal to 2. You need your variable by itself, so you need to undo what's being done to that x. And here you see we have a positive 5. We're adding 5 to x. So we want to subtract 5 in order to cancel that out. Now, as far as our equation is concerned, you have a right side and a left side of your equation, and that's set up by your equal sign. Right side and left side of your equal sign. So if I minus 5 on the left side of my equal sign, then I need to minus 5 on the right side of my equal sign as well in order to keep my equivalency. 5 and negative 5 cancels. That leaves me x on the left, and then 7 minus 5 is 2 on the right. So that's the foundation of what we'll be doing when it comes to solving our equations. Even when it comes down to having squares and square roots. Square undoes square root, vice versa. Same thing with cube and cube root. So the foundation of what you'll be doing is using opposite operations to get your variable by itself on one side of the equation. So just re-emphasizing the process, and then we'll add way more to it. All right, so if I have y minus 10 equal to 15, I want to solve for y, then I'm going to add 10 to both sides. 10's cancel on the left, leave me with just y. 15 plus 10 will be 25 on the right. The next one, 5a equal to 13. So that's 5a. 5a is 5 times a, so what I need is to divide both sides by 5. 5's cancel, leave me with a equal to 13 over 5. So 13 over 5 is fine. Notice I didn't divide the 5 into the 13, didn't convert to a decimal or a mixed number. You're not expected to do so. You don't have to. Now, that's not the same as reducing. You are expected to reduce your fractions as much as possible. In other words, write your fraction in simplest form. So in other words, if I have 4 over 6, I don't have to convert it to a decimal, but I am expected to reduce that down. They both are divisible by 2. So reduce by 2, cancel out. I have 2 over 3 as my final answer. Or in other words, my most simplified fraction. Notice it's still in fractional form, but it cannot be reduced any. So don't confuse reducing and converting to a mixed number as the same thing. You don't have to convert to a mixed number, but you do have to reduce your fractions. All right. Then this last one, x over 9 equal to 11. That's x over 9, x divided by 9. So I will multiply both sides by 9 to get that 9, or the x by itself, cancel out 9. That'll leave me with x on the left. 11 times 9 is 99. All right. Any questions?
No.
All right. Thank you. Thank you. So looking at this next one, let me erase some stuff. So here we have 2x plus 1 equal to 17. The most efficient way to handle this type of problem is not to move the 2 first, which is closer to the x, but move the positive 1, which is furthest away from the x, first. You could divide by 2, divide both sides by 2, but if you do that, then you'll end up dividing each term by 2, which will create fractions for you. And most people don't want to deal with fractions if they don't have to. So the most efficient move is to subtract 1 from both sides of your equation. The 1 cancels on the left, leaving you with just 2x. And then on the right, 17 minus 1 is 16. So we have 2x equal to 16. Divide both sides by 2. 2's cancel on the left, leaving you with just x. And then 16 over 2 is 8 on the right. All right. Next one, we have 2x, or 2 times the quantity of x minus 3 minus 17 equal to 13 minus 3 times the quantity of x plus 2. All right, so the first thing we'll do here is distribute the 2, and then here distribute negative 3, not just 3, but negative 3. And that will give us the line of 2x minus 6 minus 17 equal to negative 3x minus 6. Right. So from there, notice we have this quantity and then this quantity over here. So what I would do is simplify as much as possible on each side of the equation by themselves before I look to move anything across the equal sign. So notice I have negative 6 and negative 17. That will give me a negative 23. So that's 2x minus 23. And then 13 and negative 6. 13 minus 6 is 7. So that gives me the 7 right here. All right. So now at this point, we have 2x minus 23 equal to 7 minus 3x. I also wrote a note here that if you wrote negative 3 plus 7, it's the same thing. As long as 7 is positive and 3x is negative, you'll still be all right. All right, so from here, your goal should be to get each term with x on one side, each term without x to the other. So it doesn't matter which term you move first. You have 4 different terms, 2x, negative 23, 7, negative 3x. It doesn't matter which term you move first. As long as you stay correct with your mathematics, you'll still get the same answer eventually. So I decided to move the 3x by adding 3x to both sides. So the 3x cancels on the right. 2x plus 3x, that'll be 5x minus 23 equal to 7. All right, so now we need to move that 23. Add 23 to both sides. 23's cancel. And that'll leave me with 5x equal to 30. Now divide by 5. And x is equal to 6. All right. Questions on that one before we look at the next one? All right, so next one. We have 5 minus the quantity of 2x minus 10 equal to 35. First thing we need to do is get access to the x that's in the parentheses. The way we do that is go ahead and distribute that negative. So it'll be 5x minus 2x plus 10, the negative. All the negative does is change the sign of each term that's inside of the parentheses. Combine your like terms. 5x minus 2x, that gives us this 3x. All right, so that's 3x plus 10 equal to 35. Subtract 10. 10's cancel on the left, leaving us with just 3x. Then on the right, 25. Now to finish it off, we have 3x equal to 25 divided by 3. 3's cancel, x is equal to 25 over 3. All right, any questions? Questions? All right, next one. Have a an equation that involves fractions. X plus 2 over 4 minus x minus 1 over 3 equal to 2. So what we're going to do here is what we call clearing out your fractions. First thing we want to do is find the LCD. Don't forget your LCD is the smallest number that each denominator can divide into evenly. So when you look at 4 and 3, the LCD of 4 and 3 is 12. But also keep in mind that when you're looking at this process, the main goal is to find a number that both 4 and 3 can divide into evenly. And so what I mean by that is that let's say if you saw, or you found 24, as long as 4 and 3 can divide into it, you still can use it in this process. It's just that you'll be dealing with a little bit larger numbers versus what 12 would produce. So the best number to choose is your LCD, but if not, just make sure 4 and 3, or whatever your denominators are, can divide into it evenly. So from there, we're going to multiply each numerator by the LCD. So notice we said each numerator we're going to multiply by the LCD. That's what we did here. 12 times x plus 2 over 4 minus 12 times x minus 1 over 3 equal to 12 times 2. And be careful here. A lot of times people will forget that last term or forget the term that does not have a denominator already involved in it. Because whether it has a denominator or not, it still needs to be affected or touched by that 12 or you're changing the value of the equation. So every term needs to be affected by the 12. All right, so now we want to simplify. So 4 divides into 12 and leaves you with 3. 3 divides into 12 and leaves you with 4. So now when we go to this next line of simplifying and then solving, we see we have 3 times x plus 2 minus 4 times x minus 1 equal to 24, to 12 times 2. And we don't have any fractions involved at all. All right, so now we can go ahead and solve. We'll distribute. Here we'll distribute through 3. Here we'll distribute 4. So that will give us 3x plus 6 minus 4x minus 4. So make sure you distribute the negative 4. All right, combine your like terms. 3x and negative 4x is negative 1x. 6 and 4 will be a positive 10. So that'll leave you with negative x plus 10 equal to 24. From there, you can go ahead and solve for x by subtracting 10 from both sides. 10 cancels on the left. That leaves us with negative x equal to 14. Remember, we're solving for positive x, so we take that negative over. And our final answer is x equal to negative 14. All right. Any questions? Any questions?
No, sir.
All right, sounds good. So the next one, we're looking at rational equations. So rational equations normally, anytime you have a fraction involved is considered a rational equation, but most definitely when you have a fraction that has variables in your denominator like we have here, we have 1 over x equal to 1 over 5 plus 3 over 2x. And so we just dealt with a problem in which, we have fractions and we want to clear out our fractions. So the first move to make is to find our LCD. All right. LCD will be 10x for us in this case. So you're talking about, first of all, we have 5 and 2, talking about in our denominators. 5 and 2, the smallest number that 5 and 2 can divide into evenly would be 10. And then when you look at your x's, the smallest term that x can divide into is x. So that's why we have 10x. So now we're going to take that 10x. If we had the right steps to it, that would have been step 1. Step 2 is to take the 10x and multiply it to each numerator. right. And then step 3 is to reduce. All right, so this x is going to cancel for us. 5 is going to cancel into 10 and leave you with 2. 2 is going to cancel into 10, leave you with 5, and those x's will cancel as well. So what you're left with is 10 times 1, which is 10, 2 times x times 1, which is 2x, and then 5 times 3, which is 15. So that's why we have 10 equal to 2x plus 15. All right. So now we can finish it off by first subtracting 15 from both sides. 15's cancel, leaving me with negative 5 equal to 2x. Negative 5 equal to 2x. Then to finish it off, divide both sides by 2. X is equal to negative 5 over 2. All right. Once again, always let me know if I scroll up too fast. All right, so the next one, x over x minus 3 equal to 3 over x minus 3 plus 9. LCD is x minus 3, because that's our only denominator. So we're going to take that x minus 3 and multiply it to each numerator. So notice we have x minus 3 times x over x minus 3, x minus 3 times 3 over x minus 3, plus x minus 3 times 9. All right, so now we can cancel out the quantity of x minus 3 in the first two expressions. So doing that leaves us with x equal to 3, and then in that back we have 9 that we're going to distribute to each term. So that'll be plus 9x minus 27. All right. Next move, combine your like terms. We have 3 and negative 24, or negative 27, excuse me. That will turn into negative 24. 3 minus 27 is negative 24. So that will give us x equal to 9x minus 24. Now we need all of our terms with x to one side of the equation. So you minus 9x on both sides. X minus 9x is negative 8x, and that'll be equal to negative 24. Then to finish it off, you divide both sides by negative 8, and our answer would be 3. All right, so we have our solution, x equal to 3. Now, there will be certain times wherein checking your whole equation will be essential. We'll get there wherein you'll solve for certain equations. And because of what you've done to it to manipulate it in order to be able to solve, your solution may or may not work, even if you've done everything right. These type of problems, that's not going to necessarily be the case, but you do need to at least check the denominator. Make sure that when you plug in, in this case 3, you don't have a problem in your denominator. So what do I mean by that? Remember, our original equation was x over x minus 3 equal to 3 over x minus 3 plus 9. Now, if I were to take that 3 and plug it into the equation, I have 3 over 3 minus 3 equal to 3 over 3 minus 3 plus 9, which is 3 over 0 equal to 3 over 0 plus 9. Now, even if this plus 9 was not here, 0 in your denominator is undefined. So 0 in your denominator will always be bad for us. So if when you plug in your solution and you get 0 in your denominator, that is not a legitimate solution. So we have these 3 statements right here. Since x is equal to 3, or x equal to 3 produces 0 in the denominator, we cannot use it. X equal to 3 is what we call extraneous. It's an extraneous solution, a solution that we cannot use. Since x equal to 3 is our only option for a solution, this means that the answer is no solution. So in other words, what I mean by that, let's say if we solved this and we came down to 2 solutions. Let's say if we had x equal to 5 and x equal to 3, we know 3 doesn't work. So that means our solution would just be the x equal to 5. In this case, we didn't have another option. We just know that 3 does not work. So that means the answer is no solution.
Could you go up just a little so I can see the blue part? Thank you.
Not a problem.
Sorry, I think I missed something. So you're saying that if we're checking like a problem that we did and 0 is the denominator, then it can't be that answer?
Right, you cannot use it. If when you plug your value that you believe to be a solution into your equation and you end up getting 0 in your denominator, yes, that cannot be used.
Okay.
Mm-hmm. All right. Any questions before we go to the next one?
Could you leave it there? I'm sorry. I'm still writing it down.
Oh yeah, no problem. Just let me know when you finish. Not a problem at all.
Okay, I'm all good.
All right, sounds good. Thank you. All right, so let's go to the next one. We have 3 over x plus 6 plus x over 1 over x minus 2, excuse me, equal to 4 over x squared plus 4x minus 12. All right. So once again, first move is to try to find our LCD. So notice we have x plus 6, x minus 2, then x squared plus 4x minus 12. If you were to factor that, we see that it comes out to give us x plus 2, x minus 2, x plus 6, x minus 2, excuse me, which is a combination of each one of these denominators. So since that is the case, that x plus 6 times x minus 2 will be our LCD. So every quantity, or each different quantity, needs to be represented in your LCD. So in other words, let's say if I had the example of x minus 5, that first expression was x plus 6, x minus 5. That means x minus 5 needs to be a part of my LCD. So whenever I have a different quantity, whatever different quantities are expressed throughout my denominators, each one of those have to be a part of my LCD. All right. So the only two different quantities that we see, though, in this case is x plus 6, x minus 2. All right. So then what we do, just like before, once we found that LCD, we multiplied each numerator by the LCD. And so you see we have 3 times x plus 6, x minus 2 over x plus 6, plus 1 times x plus 6, x minus 2 over x minus 2, equal to 4 times x plus 6, x minus 2 over x plus 6, x minus 2. All right. So from here, we can cancel. X plus 6 will cancel. X minus 2 cancels. And here, x plus 6 and x minus 2 cancels. And that leaves us with 3 times x minus 2 plus 1 times x plus 6 equal to 4. All right, so with that being said, you can now go ahead and distribute and solve. 3 times x is 3x. 3 times negative 2 is negative 6. And then 1 times anything is going to be itself. So that's why you just have x plus 6. And then that's going to be equal to 4. Combine your like terms. 3x plus 1x is 4x. Then we have negative 6 and positive 6, excuse me, will actually cancel out. So that's just 4x equal to 4. Then go ahead and divide both sides by 4. 4's cancel on that left. And x is equal to positive 1. All right, any questions? And of course, because we have x's in our denominators, you would go back and check, but you can see that 1 does not make our denominators turn 0. 1 plus 6 is 7. 1 minus 2, negative 1. And same thing with the last expression. And so if nothing else, at least you know that you will not have 0 in your denominator. But if you really want to check it, you plug it in and make sure that both sides equal out to give you the same thing. All right, any questions? I think we got a couple more out of this section. Everybody okay? All right, so the next one, we have 2 times the quantity of x plus 1 equal to 2x plus 3. So go ahead and distribute that too. And I know this seems like it has less complexity of what we dealt with up to this point, but there's something special that happens with it. So when you distribute 2, you have 2x plus 2 equal to 2x minus 3. And so we have to be careful here. A lot of times when dealing with this type of scenario, people do not want to let math happen. And what I mean by that is that next move could be for you to subtract 2x from both sides of the equation. When you do that, on the left side, they'll cancel. But on the right side, if 2x minus 2x cancels on the left, then 2x minus 2x is supposed to cancel on the right as well. So what a lot of people will make the mistake of doing is writing 2 equal to x plus 3 because it doesn't feel right for x to cancel completely. But that is what happens. 2x and negative 2x cancels out completely, leaving you with 2 equal to 3. And 2 equal to 3 is a false statement. So it's not the answer, but it's a false statement. So that'll take us over here to the blue to let us know what our outcome would be. When your variables cancel, you end up with a false statement. Your answer will be no solution. And once again, I emphasize false statement because notice I didn't say when you end up with 2 equal to 3, because if you would have solved a certain way, you could have gotten 0 equal to 1, or you could have gotten negative 1 equal to 0. Either way, all three of those are false statements. Whether it's 2 equal to 3 is false, 0 equal to 1 is false, negative 1 equal to 0 is still false. So when your variables cancel out completely and you end up with a false statement, your answer is no solution. All right, so next one, 4x plus 6 equal to 6 times x plus 1. So here, distribute first. So it'll be 4x plus 6 equal to 6x plus 6 minus 2x. Combine your like terms. Over there with the 6x minus 2x, and that'll be 4x. So we have 4x equal to 4x plus 6, excuse me, equal to 4x plus 6. Go ahead and subtract that 4x from both sides. They cancel, and that leaves you with 6 equal to 6. So in this case, our variables cancel. We end up with the true statement. Our answer is all real numbers. All right. Questions. All right. Any questions out of 1.2? Before we it's only 6:16, so we'll at least touch on 1.3. Everybody okay?
So does this apply for any time that the variables cancel and if a statement is true, the answer is all real numbers?
Yes.
Okay.
Yep. And so I meant to emphasize this, so I'm glad you came back to it. So going back to that last one, the previous one, no solution means that there are no values you can plug in for your variable to make that a true statement. And then for this one, for all real numbers, it doesn't matter what you plug in. You can plug in anything for your variables, and it will still end up as a true statement.
Thank you.
Not a problem. All right, so let's touch on 1.3. Not saying we're gonna finish, but we got some time here. So 1.3 is models and applications. So basically, starting off with some word problems. So the strategy is first you want to read the problem. Of course, got to make sure you understand what's going on in the problem. Step two is to, if necessary, if necessary, write each unknown in terms of one variable. I think I messed it up. Let me go ahead and rewrite that right now. So if necessary, write each unknown in terms of one variable. All right, so you want to write each unknown in terms of one variable. Write an equation, you want to solve it, and then check. So your most challenging steps will be step 2 and step 3. That's why I put the asterisk beside them. And you'll see what we mean when we get there. What's going on here? Okay. And number 5 is essential because you do want to make sure you have actually answered the question. Sometimes your X, your variable, whatever it is you solve for, may not actually answer the question, but it'll still help you to answer your question. And you'll see what I mean when we get there. All right. So let's look at the first one. Let me erase some of this stuff. All right, so let's look at this first word problem. The average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by 45,000. Combined, they earn $214,000. Find the yearly salary of each. So I'll give you a chance to write that out. All right. What is this? So I guess we're good to go. Good to go. All right. So the first thing you want to do, remember the first step is to read the problem. Make sure you understand the problem. The second step is to establish your unknowns. See how many unknowns you have and what are your unknowns. So we look at what we have here. The average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by 25,000. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by 45,000. So notice we have 3 unknowns here. We have the bachelor's degree, the person with a bachelor's degree. Then we have the person with the associate's degree. And then when we go to the next sentence, we have the man with the master's degree and a man with the associate's degree. So that's the same You know, associate degree is associate's degree. So we have three different levels of pay: man with associates, man with the bachelor's, man with the master's. So now, when we go back to writing this unknown, number two, if necessary, write each unknown in terms of one variable. So what we don't want to do is call the associates X, bachelor's Y, master's Z, because what will happen is the more unknowns you introduce into your situation, the more equations you will need in order to be able to solve. So then you have to set up a system of equations. So what we want to do is call one unknown X, and then write the other ones in terms of that X. And so with the problems that you will receive in this section, you will be able to do that. So you only want to introduce one variable and then write your other unknowns in terms of that one variable. So if you look at how these sentences are set up, the average yearly salary of a man with a bachelor exceeds that of a man with an associate's by 25,000, and then average yearly salary of a man with a master's exceeds that of a man with an associate's. So notice the associates is connected to both of your other degrees, so we can let that be equal to X. Now, look, going back to your first sentence, the bachelor is described in terms of the associates. That person exceeds the associates by 25. So I would call that X plus 25. Then the next one, the master's exceeds the man with the associates by 45. So it'll be X plus 45. All right. So now, any questions on that before we go to the next piece, number three? So number two is establishing your variables, or establishing your unknowns, and then assigning your variables. All right. And so looking at three was writing the equation. And the key word here, there will always be a key word or words that will let you know what to do with these unknown, these expressions that represent your unknown. And the key word here is combined. Combined, they earned $214,000. So that means I'm going to add them together. X plus X plus 25, X plus 45 equal to 214. And I just put the parentheses there just to signify that we're adding each one of those quantities. All three were separate. So combined is what tells us to add them together. And 4 is go ahead and solve, so we don't necessarily need those parentheses. So we have X plus 25 plus X plus 45 equal to 214. Combine your like terms. X is 3X. 25 plus 45 is 70. Subtract 70 from both sides. That would be 3X equal to 144. Then divide by that 3. Threes cancel. X is equal to 48. Now, before we go any further, questions on what we did there?
So basically the answer is just telling us that's what each of them made every year, or like what are
Well, we haven't gotten there yet.
okay.
I just want to make sure we were okay with getting to this point. We're about to get into what the answer is right now. All right. Good question, since you took us there. Now, this was what I meant by you can solve your equation and still not necessarily have the answer. Remember, step 5 was to check. It says find the yearly salary of each. And I believe that's what she was alluding to, where in here we have X equal to 48. Well, now we need to figure out what is the salary of each. And then we will find that is by going back to what the algebraic representation is for our unknowns. So X is equal to 48. So we know we have 48 right here. This next one is going to be 48 plus 25, which is going to be 73. And then here is going to be 48 plus 45, which would be 93. And those would be your 3 salaries. And remember, all 3 of them should add up to give you now 214. And so you can always, add them up and make sure that works out for you as well. All right, any questions before we look at least one more? All right. All right, so let's look at this next one. Your local computer store is having a sale on cameras. After a 40% price reduction, you purchase a camera for $276. What was the camera's price before the price reduction? All right, I'll give you a chance to write that up. All right. So once again, your local computer store is having a sale on cameras. After a 40% price reduction, you purchased the camera for $276. What was the camera's price before the price reduction? So whether you work at retail or not, if you take a step back and look at the actual sale process, there are 3 pieces to the sale process. In other words, you're going to have an original price, you're going to have a price reduction, and then the sale price. So you have your original price minus a price reduction, and then that ends up with the sale price. So that's going to be our equation. Original price minus the price reduction equal to the sale price. Okay? So we need an algebraic representation for each piece in order to be able to actually solve the equation. So let me write this. So the original price is unknown to us. That's X. The sale price they gave us, which was $276. Now the price reduction, we know that there's a 40% price reduction, but the 40% is not going to go in there. Well, first of all, don't forget when you convert it to a decimal, that's 0.40. But it's not like you're going to put 0.40 right here. All right. So it's not going to just stand alone. That's 40% of something. In mathematics, of means multiplication. And the only thing that existed in this equation initially was the original price. So the price reduction is going to be 40% of the original price. And our original price is X. So this is going to be 0.4X or 0.40X. If you want to include that 0 behind the decimal, that's fine. But 0.4X. So that's going to be X minus 0.4X equal to 276.
Could you explain how you got the 0.4x again?
Well, we got the 0.4 from right here, the 40%. And then when you're talking about 40%, you're doing 40% of something. So that 40% will never stand alone. You should not do X minus 0.4 equal to 276 because the 40% had to be applied to something. So if you're talking about of something, it's of the original price. And our original price is X. We don't know what it is. So that's why it's 0.4X.
Okay, thank you.
All right. So the next step, notice we have 2 terms that have X involved. We need to combine the like terms. Be careful with this. A lot of people make this mistake. There's a 1 in front of this X. So we're actually doing 1 minus 0.4, which would actually give us 0.6. All right. And then from there, once you have 0.6x equal to 276, go ahead and divide both sides by 0.6. And 460 would be the answer. So $460 would be the original price. All right, any questions? All right, we got one more. Oh, we got the length of a football field. Just trying to see how many more. Okay, two more problems. That's 633. So if I do these two problems next class, do that. What's 1.4? Complex numbers. Well, we can I had two really quick. We can pause right here. This would be a good place to pause. So next class we'll do these other two word problems, and then get into finish up 1.3 and then get into 1.4. Okay, that'll be fine. So check this stuff out. See if you have any questions or concerns. Feel free to ask them, whether it be through email or even next class. I sent you the links from my lectures from last semester, covering the same topic, the same examples and everything. So if you want to move ahead, you can always feel free to do so, whether it's by my old videos or just want to move ahead. Everything's open, and you're able to take your first test, at your leisure. Just don't forget that when you after you submit your test, you send me your scratch work. All right. So any questions before we close out for the weekend? Everybody good? Everybody straight?
Oh, I have a question.
Yep.
So so I was kind of trying to follow you on Monday with the assignments on my math lab being due the last day. So when will our homework be due for chapter 1?
When we get closer to closing out chapter 1's topics. So
Okay.
there are 8 sections. I think it goes to 1.8. So around 1.6, or 7, I'll put a date out there and say all of your homework from chapter 1 should be due by this date.
Okay.
So and that, of course, that's with the anticipation or the expectancy that you guys are doing your homework. It's not like I'm asking for all of 1.8 if you do right now. So
Okay.
like you know what I mean? So like you guys are
Yeah.
supposed to be keeping up with the lecture and doing homework as we progress throughout the course. And then so really what I would be asking of you is just to finish up stuff versus really you doing 8 sections and be done like tomorrow. So I think what I'll do is give you a week from that point. It will be a week due, but like I said, that's not anywhere time soon because we have to get there. So
Okay.
yeah,
Thank you.
not a problem, not a problem. And we'll do that at each as we step into each chapter. So that's why the dates would not be adjusted for chapter 2 until we get almost finished with chapter 2. And same thing with chapter 3 and so on. As a matter of fact, you guys actually have a midterm and they want a progress report. So what will probably happen for you guys, and I forgot because I got different schools that I teach at, what I probably would do for you guys is that I know for a fact at least chapter 1 and chapter 2 will be due by midterm. That's probably what I'll do. Chapter 1, chapter 2 stuff will be due at midterm, the end of midterm week, so I can do an actual assessment for you guys, and then go from there. All right. Anything else? Anybody else before we close out today? Everybody good? Okay, great, great. Um, so that being said, you guys have a great weekend. Also, don't forget Monday, no class. So I will see you on Wednesday. Have a great weekend and see you Wednesday. Take care.
Bye.
All right.